All right, folks, it's back in action here. In this video, we're going to look at systems of nonlinear equations. So it's just what it sounds like. The equations won't all be lines like we've done in the past. What I'm going to have you do is actually pause the video and try to graph as many of these functions that I have on this page as you can before you come back and actually check your work. The first one, however, you might need a little bit of help on. When we look at this first one, it looks like something that we're, don't really know what to do with, because we know how to do a square root function and we would know how to do a quadratic, but combining the two together doesn't look very familiar. So what I've done here in blue is I've squared both sides of this equation to start to get this into a form that I might be more familiar with. Once I get it to here, I can take this negative x squared and I can move it over to the right. And when I do that, what I can see is that I have the equation for a circle with the center at 0, 0 and a radius of 2. Now, I don't want to actually graph that entire circle. I only want to graph the top half of it. I'm graphing the top half because I can see that in front of my square root sign here, I have a positive, an implied positive. So I'm just going to graph the semicircle, that's the top half. Other than that, the rest of these should be pretty straightforward for you to graph. So go ahead and graph those, and then come on back and we'll work through the algebra and talk about how the algebra and the graphs should match up. Okay, so now that you have those graphed, let's take a look at the algebra aspect of this. On our first one here, what I want you to notice is that both of the equations have already been set equal to y, which means a simple substitution is going to be an easy strategy here. We can just set them equal to each other, which is what I've done right here. So I have my square root of 4 minus x squared, and I have my 2x plus 4. This is really just algebra, so we've got to remember to take off our pre-calc hat and just think algebra. To solve this equation, what I'm going to do is I'm going to square both sides of this equation. So the left-hand side will become my 4 minus x squared, and on my right-hand side, I'm going to need to remember to FOIL this whole thing out. Once I get to here, I can start to just move everything over to one side to set it equal to 0. It's really important, make sure to check your work that you don't lose that equal sign. It is where students start to make some mistakes. Now, once I get that over to the right-hand side, I'm going to go ahead and try to factor this. And this problem does, in fact, factor. So if I factor this, I'm going to get a 5x plus a 6 and an x plus 2. That, of course, will give me an x equals a negative 6/5 and an x equals a negative 2. Now, when I do that, what I need to know is that those are the x coordinates of separate ordered pairs. Okay, this is where students do struggle. So I have an x equals a negative 2, and I have an x equals a negative 6/5. When I do that, I'm then going to take those x coordinates individually and plug them back up into either one of my equations. It doesn't matter. So when I plug it back into, let's say, the line, because that'll be our easiest, we get at x equals negative 2, I get a y value of 0, and that makes sense on my picture. When I plug the negative 6/5 back into my equation, I'm going to need to do a little bit of work algebraically, or really more arithmetic. So I'm going to have my 2 over my 1 times my negative 6/5 plus my 4. I'm going to need to get my common denominators there, so I'm going to do a 5 over a 5. So I'm going to have my negative 12 plus my 20 in my numerator. That's going to give me a negative 8/5. And although you might not be able to see it super perfectly in your picture, you should be able to confirm that these points look pretty reasonable for what you have on your graph. You'll notice that here on my iPad, I can't really quite see those ordered pairs, but these points seem reasonable for what my graph is looking like. Let's take a look at the next one. On the next one, I'm going to use substitution as well, but this time my two equations can't just be set equal to each other. This time what I'm going to do is I'm going to notice that the second equation is set equal to y, And my first equation has a y squared. So I'm going to do a substitution there. I'm going to take this entire x plus 2 and I'm going to substitute it in. And you can see that that's what I've done on my algebra here. And again, I need to remember to FOIL this entire expression. Once I get that FOILed, I can move everything over to the right-hand side. And you're certainly welcome, by the way, to pause this video and try as much of this algebra as you can, because again, we're taking off our pre-calc hat and we're just working with our algebra. Once I get everything moved to one side, I can factor again. So I'm going to get an x plus 3 and an x minus 1 equals 0. Again, that's going to give me some x coordinates of two separate ordered pairs. So an x coordinate of a -3 and an x coordinate of a 1. I can plug those back into either equation, but the line's going to be the easiest. So when I plug it back in, I get a -1 when x is -3, and I get a +3 when x is 1. And those two ordered pairs totally make sense for what I have here on my graph. My last system that I'm going to work with, yours probably already looks right. Mine I've had to hand correct. What I'm going to do here, we should have our circle and our square root. And again, I'm going to do some substitution. This time I have my y here. I'm going to substitute it here. And I'm going to jump into my algebra. I've got a couple things that I'm going to expand first. My x plus 2 quantity squared is going to FOIL out, and then my square root of x plus 5, when I square that, is just going to simplify very nicely. So again, once I get all of that FOILed out and moved over to one side, we're back to a good simple algebra question. And we've talked about this one a lot. Remember, we want to factor out that GCF to get this x plus 5 equals 0. It's going to give us some x coordinates of a 0 and an x coordinate of a -5. I can't emphasize enough keeping track of these values and just putting them right into separate ordered pairs. It'll really help you keep track of what you're doing. So if x equals 0, I'm going to work with my square root function. If x equals 0, then my y coordinate is the square root of 5. And if x equals a -5, then my y value is 0. And again, those ordered pairs match my graph. So I would really encourage you to try this algebra, as much of this algebra as you can on your own. Maybe even just go back and try it again on a blank piece of paper, and then we'll just do some more in class.